When you're building APIs, it's always tempting to think about how do you future-proof things, so throwing some extra key value pairs and a little collection in there sure does feel good. But today we'll dig into why that might set you up to be a not good API. That's what's coming up next. Hey, welcome back to the workshop. I'm Jason Harmon. Today is the first in our series called Not Good APIs. And really what that's about is developers early on in learning API design, maybe early in their career, take a look at how to deal with designing an API, and they kind of apply some maybe concepts that worked in other programming disciplines that really set them up for problems. And I see these kinds of things all the time. In fact, I sort of collect them. I say I'm a collector of mistakes. So that said, it's a design discipline, and that means that there's not always a perfect answer. Sometimes the answer depends, and everybody hates the depends answer, but it's a reality. So what we want to do today is kind of look at the generic case of, a bad idea that doesn't work out well in the long term. And ultimately what we're most concerned about, and really the whole purpose of this sort of workshop environment, is thinking about API consumers and what happens to them when we apply some of these ideas. So that's kind of the not good APIs thing. That's what we're going to be looking at. And today specifically, as I mentioned, we're going to be looking at key value pairs, or kind of key value constructs, which is sort of a broadly known concept across programming. And I think anybody that's an established, experienced programmer is going to know programming by hash map, if I say that, means to you some bad things. Well, in API design, it kind of means some bad things too. So when you're first getting started designing an API, it's a little scary to think that, hey, whatever I put here, I can't get rid of. I need to be able to extend this. So I want to kind of put out the bare minimum and keep adding to it as time goes on. And that's great. However, looking for little tricks and solutions that ultimately get you some kind of ability to grow and change without changing your contract, without changing the shape of your API, that's where guys get into some trouble. The trick here is that we always want to balance extendability, kind of this ability to change your design, balance that against usability. Because sometimes these kind of key value things set up some usability problems. So first, I want to look at a fictional example. And if you've hung around me much, I always talk about the imaginary factory. There's a factory and it sells and makes parts. And so first we're going to look at a parts API. And I know you might be telling me it should probably be a products API with a type of part or something like that. But bear with me, we're just fictionalizing an example to explain a premise. It could really happen in any API. And we'll also use JSON in our API, really just because that's what most APIs are using nowadays. But a lot of these concepts that we're looking at today could definitely apply to XML or YAML or whatever other media type that you're using. Okay, so we have get/parts/prt-3213, whatever, some part identifier. And, normal stuff, name, description, status, pretty unexciting. But then paranoia takes over and you imagine a smoke-filled room full of product managers ruining your life by adding a whole bunch of fields you didn't think about. So in our next sample here, we got our get/parts/prt-3213, same resource. But now we've got name, description, status like before, but now there's this attributes field. And the attributes field is really an array of objects, and those objects contain a key and value. And as you can see here, the key is inventory ID, which, you could imagine in a part database might make sense. And there's some value to it. So seems innocent enough, right? You could go back later and maybe add some other fields. We've got inventory ID in there now. Maybe we could go back later and add like a purchase order number or whatever related IDs. We might add like, custom inscription on that part or whatever else comes up. And we have no need to change the defined contract. We know that the array contains an object with key and value, and we can add an infinite number of items to that array. Congratulations, you have a future-proof API. However, as I mentioned earlier, let's look at usability because I think that's where we're going to find out this kind of falls apart on us. So let's say that we want to retrieve the inventory field in our resource. We'll look at this in JavaScript, the code that you see here, but the concept is true in most languages. There's definitely some fancy array handling concepts in some languages, but it's not like a general rule. And we can kind of look at some of the fancier ways to do this in JavaScript. But fundamentally, you're going to need a function in your client code. I'm calling it value by key here, and it takes the array object and whatever key you're looking for. There's not like a built-in way in most languages to get a key value pair array to look that up by ID. And some do, I get it. But, if you look at the broad swath of programming languages out there that clients would typically be written in, this kind of stuff happens. Within your function, you're going to need to loop through the array. In this case, we're kind of going through this, OBJ parameter, the object that's getting passed in. We're iterating through it, and if the object.key within that particular array item equals the key that was passed in, then we're going to return the object value. And so the call looks something like value by key. I pass in my response object dot attributes and the inventory ID that I'm looking for. So a little bit exhausting to look at. And I know you JavaScript guys are probably complaining right now that nobody on earth does this anymore. There are libraries that deal with this. So fine, cool. Let's look at it. I'm going to go ahead and use Lodash, which is kind of like a faster underscore, I guess. Kind of just learning about it myself. So first I've got to install it from the command line, npm install Lodash. Then I've got to make a reference to Lodash in my code. So now I have a new dependency. So I've got, in this case, I'm using var u equals require Lodash, because in the sort of command interpreter, you can't override the underscore. So anyways, then I can do u.find, pass in the response attributes to a delegated function with an object, and if the object key equals inventory ID, then I get the dot value. Okay, so I don't know about you, but to me, that's a lot of steps to get a field value. We either have to do some sort of loop iteration and call a function. Now I've got to have maybe some file full of functions that deal with these different structures, or I've got to add a dependency to my client code for dealing with objects of key value pairs on how to look up things by key and get the value. It's a lot just to get a value, and it's annoying if you're a client developer who's just quickly trying to prototype something up, that you've got to go and maybe you've never used Lodash or underscore. In my case, I actually hadn't used them from Node before. So this one little sample took me 30 minutes to get running because I didn't realize I couldn't override underscore, the underscore character, and both Lodash and underscore do that. So, it's just an example to me of where, hey, if you really try writing client code against your API, you're going to find out you've created complexity. So thankfully, in looking for APIs which use this construct, I think many of you fellow API designers out there have fought hard to keep them off the internet and keep them more appropriate in usage. But it was interesting that somebody pointed out to me that APIs.json, the format for describing APIs as a search, project with Ken Lane and Steve Wilmot from 3Scale, they're actually using this concept. So if you go to apis.json and we go down and look at the properties field, and it should be noted that when you see attributes or properties as a field in a JSON resource of some sort, that's usually kind of the calling card for these sorts of problems. So when we see properties, it seems fair. We have these sort of X dash definitions, which really are user-defined values, and we'll talk about that a little bit later. What I do notice here is that like Swagger defines the Swagger definition for this particular API. So essentially we're describing an API as a resource. The interesting thing is when we go look at the reserved keywords in the actual spec, and there'll be links below in the description that sort of show you how to get to these things, that in the reserved keywords, Swagger is actually in the properties elements as a reserved keyword. So I think in this example, Swagger, Raml, Blueprint, Waddle, WSDL being the reserved elements, you sort of have to question, maybe these would have been better as first-class properties, perhaps under maybe a definitions object, something like that, which would allow for us to more easily, as a client of this, although it's maybe not exactly an API, it's kind of a description of an API. Nonetheless, if we're writing code against it, we'd be able to refer to this Swagger property as a field versus having to dig into this properties array to try to dig out by key a reserved keyword. again, not an API, but a good example of a structure in JSON which kind of reflects what I'm talking about. So if we just look at another sample where all we do is add the field, you'll kind of see the difference. And this isn't going to take us long. Okay, don't blink. Here it is. Response.inventory ID. That's it. If we just if we look at our JSON object and it now has an inventory ID field and it has a value, our client code, when we've got an object, response.inventory ID to gather the value. That's it. That's all. So as you can see, there's serious usability problems with key value pair structures, and just adding the field is pretty simple and works. There are some other issues to this that we should really cover. First of all is that if you're using like a Swagger or RAML or apiary or something like that, they don't really provide a mechanism to define a library of, sort of enum values or key values like this. So you're going to be left to documenting, in our case, the attributes field as one gigantic piece of documentation that lines out what every single key means. And I'll tell you from experience, these structures are like the junk drawer of the internet. People will just sort of throw things in there on the back end without telling anybody, without changing the contract. And you're going to end up with undefined parameters in your key value structure. If you're using sort of a contract mechanism, again, Swagger, RAML, apiary, stuff like that, you kind of need to describe what each field means. When you just add a field, it's hard to mess up for the client to understand that this field means this, versus I need to understand how this array structure works. I need to know what each of these keys means. Hopefully their documentation's good. In most cases, AutoGen documentation comes out a lot better from these sort of defined contracts. So the other thing, if you compare these two responses, one's bigger for sure. And granted, gzip and all that kind of stuff washes away most of the sins of this one. But ultimately, you've got a bigger response. And if you start overusing these key value structures, it does make a bigger response for sure. So mobile developers, for instance, are super sensitive to payload weight. So this is definitely an operational issue for them as well. And again, just to underscore, this is harder. It's harder all the way around. It's harder for the server developers too. You're not binding to a hard type here. You don't have a field that you can statically reference. If you're in, say, C# or Java, you're coding by magic strings, and you have to know what all the magic strings are on both sides of the equation. There's a lot more potential to screw this up. All right, so the fundamental concept that we want to grasp here, that I'm rather shocked sometimes at how often people misinterpret, is that, especially with JSON, JSON is key value pairs. Let's look at the Wikipedia definition of JSON. JavaScript object notation is an open standard format that uses human-readable text to transmit data objects consisting of attribute value pairs. And if you look at the link down in the description, you'll see that attribute value pairs, if you dig into that Wikipedia article, is a description of what I've been calling key value pairs. It's just a synonym. It's the same thing. So, this is kind of true with most data structures that we use in APIs. It's just key value pairs. So adding another layer of abstraction, adding arrays of any kind, you're just adding complexity. You didn't really accomplish anything with it. You just made everyone's lives harder. So sounds harsh. That's the truth. And that's kind of how it tends to play out. So the other piece that we want to be sensitive about is contravariance and covariance. All right, maybe you missed it in your CS course. Frankly, I never took one. I never actually accomplished my CS degree. I got a job doing tech stuff and dropped out. And I never actually took any CS courses. I just kind of learned it all. But I've met some smart people who pointed out contravariance and covariance, notably Peter Graf, a guy that I've met through PayPal. Brilliant, really sharp guy. Basically, the Wikipedia definition, if you go look this up, is pretty terrifying. And there's fancy math notation. It's really scary. But it really boils down to a simple concept. Contravariance allows a smaller or more specific type to be substituted in an API where the original type is only used in an input position. So what that means is you can make your required fields less precise or a smaller object, but you can't add new required fields when it's coming in. So again, we're just kind of defining backward compatibility here. The other is covariance, which is that it allows a bigger or less specific type to be substituted in an API where the original type is only used in an output position. So what this means is you can add fields to your response in your API and nobody gets hurt. So again, if we keep in our heads that JSON is a key value pair structure, it's true, and we want to add a field, then we've accomplished the same thing that programmers had in their head about creating this arbitrary key value structure and then adding stuff to it, that they know that doesn't break things. The hard part to get through to everybody is that JSON is the key value pair structure. That's how we do everything. So sticking to that allows you to document it better. It allows for concrete types on both sides of the equation, which makes everybody's lives a little easier. So, that's kind of the takeaway here is use the key value pair structure that you get for free. Don't try to make your own. So I said before that everything that we do in the design discipline, there's a depends. There's almost no perfect answers. And that's definitely true here. So we want to take a look at an example today. And it's really focused on the notion of client supplied data. And it's like, maybe there's a better term for this. Please comment if you have a better term for me here. But where API consumers self-define fields, that's where all of a sudden this key value construct becomes super useful. And it's definitely where we swing the balance toward sort of utility and away from usability, but for the benefit of the clients to be able to define what they want. Now, I have seen where some fancy, APIs are able to actually allow clients to supply their own JSON object and the server can deal with it. But in a lot of cases, this key value pair stuff kind of makes it a little bit easier to implement where you don't have to do such fancy stuff or have sort of scary, undefined objects coming into your system. So let's take a look at our example from before with, or a different example actually. We're going to take a look at basically like a bug tracking system, issue tracking. So a common concept in these APIs is that they have client-defined fields, custom fields. So let's take a look at our bug here. So we've got get/issue/bug-3213. Yes, I like 3213 in samples. I don't know why. So we've got a description of the bug. Of course, it's a bug in IE. If you've done any browser coding, that's always the problem. So notice here that we have a custom field set. And in the custom field set, we define a field and a value. Again, this is just kind of a key value set. We're just saying field here because the product would probably say that you get to define custom fields, so this reads nicer. And in this case, we're saying there's a legacy issue ID. Maybe you have an old bug tracking system that you want to tie this back to. Maybe you're doing an import into the new system, kind of big migration. So this is actually super useful. Now, all the things we said before about the code are still true. It's still harder to deal with. However, now the client can define their own fields and the server doesn't necessarily have to know about it, and the client can use those values to actually better integrate their systems. Okay, so now that we've seen an example of a fictional issue tracker, let's take a little look at a real issue tracker. In this case, it's Zendesk. Now, frankly, I struggled to find an example that was simplistic enough to cover in the time that we have here. But in Zendesk, they do have this custom field options where you can specify, again, a name value pair. Now you'll notice they also have to add an ID that goes with this to identify that name value pair. So the example that I gave before in dealing with name value pairs and the complexity involved, in this case, you also have to keep track of the ID that's paired with the name and value. Now, their docs are a little bit thin on describing this concept. It's really only kind of pictured in the put operation where you're updating the custom field options. But you can see in that put, we have an ID, a name, and a value. So if you want to update the name and value in that resource representation of the ticket fields, you're going to have to also pass along an identifier. But again, this certainly sacrifices some usability, but ultimately you're able to keep track of custom name value pairs in the scope of your Zendesk ticket. So this seems like one of those situations where we've sacrificed a little bit of usability for the utility of the client. And, I think it works. There's certainly probably better ways to do it, but, it's always a tricky thing. It's a depends. And those are never completely certain. I'd love to hear your experience with dealing with key value pairs and APIs, either in an API that you've used where it seemed to work well and you didn't see a problem with it as a client, or in your sort of API design practice where you feel like this is a good approach in your given situations. So please share in the comments below, and let's collaborate and let's share our experiences and kind of make this a repository of knowledge. So in closing, that's it for today's Not Good APIs about key value pairs. Be sure to subscribe to the channel if you want to keep up on other API design issues, other not good APIs. But also, we've got some other things on tap with interviews with API design figures you may recognize, as well as kind of some basics coverage. I think this topic today is kind of maybe intermediate. If you've never dealt with REST APIs, maybe a little disorienting. So we've got some things coming up to cover the basics as well. So again, subscribe, comment, share. Let's keep working in the workshop, and we'll talk to you soon.